go there. Okay, so given a problem that there's chickens and cows on a farm, 47 heads total, and 146 legs, we want to know how many chickens and cows are there. Well, the first thing to know is how much heads a chicken has and how much heads a cow has. Now, assuming no genetic mutations or anything like that, a chicken has one head and a cow has another. So if we say chickens X, cows is Y, it could be vice versa, but that's just how we're going to do it. And that's the number of chickens, so let's write that. Number of chickens, number of cows. Okay, so then we know that X plus Y equals 47. Because if you count all the heads on all the chickens and all the heads on all the cows, there will be 47, and they both have one each. Okay, and now it says there was 146 legs. Well, how many legs does a cow have? 4, right? So 4 legs per cow, so cows are Y. And then we know that there is, chickens have 2 legs. So there's 2 legs. There's 2, that's X. And we know that all the legs total equal 146. Well, now we just have a system of equations. So let's write that as a system of equations. So we have 4, let's actually write it in the same order. That'll just make it a little easier. So we have 2x plus 4y equals 146. And then we have x plus y equals 47. Okay, so now I'm going to get rid of these. Because I already have them restated right here. So this is a system of linear equations. Linear because they're all to the power of 1, but that you don't really need to worry about that too much. Okay, so how do we solve this? Well, let's take this equation here and solve it for y or x. It doesn't matter which. I'm going to do y because I feel like it. So from this, some basic algebra, we can get that y equals 47 minus x, right? So we subtract x from both sides. Okay, so now we know what y is in terms of x. So let's plug it into this equation up here. So we can do 2x plus 4. Now we know y equals this. So 47 minus x. And that all equals 146. Okay, so now we just have to do some basic algebra to distribute this out. So we say 2x plus 47 times 4 minus 4x equals 146. 47 times 4, you can use a calculator, but my calculator on the phone is over there recording this video, so I'll have to actually do math. So let's see. 4 times 4 is 16, that's times 40 is 160, and then 4 times 7 is 28, so that puts it at 188. Is that number? Okay, so let's write it like that then. So 188. Okay, so now we can do some algebra. Let's combine these. That'll put, 2 minus 4, that's negative 2. Okay, so now let's add 2 to this side and subtract 146 from both sides. So I'm just going to write it down here. So we're going to move the 2 over so it's on its own side. And then we're going to take 188 minus 146. So let's see, do it like that. That'll make it a little easier. So we got 2, 4. Okay, so that's 42. So we have 42 equals 2x divided by 2. X So then x equals 42 divided by 2 is 21. Boom. So that's how many chickens we have, right? Yes. So now from that, we know that chickens plus cows equals 47. So 47 minus chickens equals cows, which is the same. You could plug that into here and solve. So 47 minus x equals y. So then that would be 26 cows. Okay, so that's the answer to that. I'm gonna quickly do that in another way that is a little easier and doesn't involve as much algebra. Show you kind of a shortcut here in a way. So what we can do is if we take the coefficients of each of these, leave them in the same order, then we can say 2, 4, 146, and then we have 1, 1, 47. So this here is what's called, we can make a matrix out of this. So this is a matrix. So if we can put this matrix in what's called reduced echelon form, it will give us our answer to a system of linear equations. So what we're going to do is take row 1, and we're going to subtract row 2 from it. So we're going to do row 1 minus row 2. So these will stay the same on the bottom, 1, 1, 47. But from row 1, we're going to subtract these. So that leaves us with 1, 3, and then 146 minus 47 would be 99. Okay, and now I'm gonna, so my goal here is to get it to be a 1 and then a 0 here, and then a 1 and a 0 here. So I need to do some more manipulations of this. So what I'm gonna do now is take row 2 minus 1 row 1. So I do row 2 minus row 1. So row 1 stays the same now because I'm working on row 2. So then we have 1 minus 1 is 0. 1 minus 3 is negative 2. And then 47 minus 99, let's see here, that would be 2, 5, negative 52. Okay, all right, so now this is a 0. So now what we can do is we can start using this side here a little more. Let's see here. I'm going to divide this side by negative 2, or not this side, this row. I'm going to do row 2 divided by negative 2. So then row 1 stays the same. And then row 2 becomes 0. Negative 2 divided by negative 2 is just 1. Negative 52 divided by 2, well, the negatives cancel out, so it's positive. And then 52 divided by 2 is 26, I believe. Yes. Okay. So now we need to get this to be a 0 up here. So if I do row 2, row 1, and then I minus 3 times row 2, then that will make this 0. So I do row 1 minus 3 row 2. So now I have 1, because 1 minus 3 times 0 is just 1. 3 minus 3 times 1 is 0. Then 99 minus 3 times 26. Well, what's 3 times 26? That would be 78, I believe. Let's see, 60, yes, 78. So 99 minus 78, that puts it at 21. And then we have 0, 1, 26. So then that gives us, so from that, so this is the x's, this is the y's. So we can write this as a system of equations saying x plus 0y equals 21. And then we can say 0x plus y equals 26. Well, 0 just makes it go away, so then that means that x equals 21 and y equals 26. So that's another way you could do it. I think it's easier than the algebra. It takes a little bit longer sometimes, depending how many steps to do. I could have combined a few of them, but that's a fun way of doing it, I think. So there you go, and that's how to solve this problem using algebraic and then using linear algebra.